In the previous video, we looked at building hidden Markov models for sequential data. In this video, we're going to use conditional random fields to analyze structured data. We'll also use it to label and segment sequential data. The conditional random fields, CRFs, are a probabilistic models to use to analyze structured data. They're frequently used to label and segment sequential data. CRFs are discriminative models as opposed to HMMs, which are generative models. CRFs are used extensively to analyze sequences, stocks, speech, words, and so on. In these models, given a particular labeled observation sequence, we define a conditional probability distribution over this sequence. This is in contrast with HMMs, where we define a joint distribution over the label and the observed sequence. HMMs assume that the current output is statistically independent of the previous outputs. This is needed by HMMs to ensure that the inference works in a robust way. However, this assumption need not always be true. The current output in a time series setup, more often than not, depends on previous outputs. One of the main advantages of CRFs over HMMs is that they are conditional by nature, which means that we are not assuming any independence between output observations. There are a few other advantages of using CRFs over HMMs. CRFs tend to outperform HMMs in a number of applications, such as linguistics, bioinformatics, speech analysis, and so on. In this video, we'll learn how to use CRFs to analyze sequences of letters. We'll use a library called PyStruct to build and train CRFs. Make sure that you install this before you proceed. You can find the installation instructions at this web link. So let's go to the editor. We first create a new Python file, crf.py, and then import these packages. Next, we define an argument parser to take the C value as an input argument. C is a hyperparameter that controls how specific you want your model to be without losing the power to generalize. Now let's define a class to handle all CRF-related processing. Then we define an init function to initialize the values. We use chain CRF here to analyze the data. We also add an error check for this, as here. Now define the classifier that we'll use with our CRF model. We'll use a type of support vector machine to achieve this. We now load the letters dataset. This dataset consists of segmented letters and their associated feature vectors. We'll not analyze the images because we already have the feature vectors. The first letter from each word has been removed, so all we have are lowercase letters. Let's load the data and labels into their respective variables. Then we go ahead and define a training method as this. Then define a method to evaluate the performance of the model. After this, we define a method to classify new data. The letters are indexed in a numbered way. In order to check the output and make it readable, we need to transform these numbers into alphabets. Let's define a function to do this. Let's define the main function and pass the input arguments. Now initialize the variable with the class and the C value. Let's now load the letters data. And then we separate the data into training and testing datasets. Let's now train the CRF model as here. And then we evaluate the performance of the CRF model. Take a random test vector and predict the output using the model. At last, we are now ready to run this file, so we move on to our command terminal. The full code is given in the crf.py file that's already provided to us. As we run this code, we get this output on our terminal. As we can see, the word is supposed to be commanding, but CRF does a pretty good job of predicting all the letters. In this video, we've used conditional random fields to analyze, label, and segment the sequential data provided by us as input. In the next video, we'll look into analyzing stock market data using hidden Markov models.